Welcome to Protecting Data in Transit. This will be a multi-episode course, and today we'll be covering cryptography. My name is Payam Hojat, and I'll be your guide today, so let's go ahead and begin. So prerequisites for this course. The first is computer fundamentals. This will be important to understand the theories behind cryptography, but this is also an introductory course, so it is important to be open-minded and to have a curiosity for learning. Learning objectives for this course are to be able to understand theories of cryptography and encryption, to be able to understand the differences of substitution and transposition ciphers, and to be able to understand the differences between symmetric and asymmetric encryption. But before we start, I'll give a quick introduction of myself. My name is Payam Hojat. I'm the Chief Information Security Officer over at the Department of Toxic Substances Control. I have a bachelor's in Management Information Systems and a master's in Cybersecurity and Information Assurance. Cool fact about me is I'm the youngest CISO ever in the state of California in the public sector. And feel free to connect with me on LinkedIn. If you have any questions, do not hesitate to email me at payam.hojat@dtsc.ca.gov. And now this course is for you if you are an IT professional looking to explore the domain of IT security, if you're a security analyst, data engineer, or mathematician looking to improve your understanding of cryptology, or just studying for your Security Plus, GIAC, or CEH certifications. Materials you'll need for this course are a computer, internet access, and potentially pen and paper if you like taking notes by hand. And now let's go ahead and dive into cryptography. Cryptography is a method of protecting information and communications through the use of codes. We use cryptography to convey a message in privacy and to ensure confidentiality. And now encryption is the actual means of using cryptography. It's the process of converting those messages into an unreadable or secret language. And on the other hand, decryption is the process of converting an encrypted message back to its original state or form. An example of such could be like a decoder ring. Now there are several inputs and outputs in regards to encryption. The first being plaintext. Plaintext is the actual input into an encryption algorithm. And after the plaintext has gone through the algorithm, the output is called the ciphertext. Ciphertext is the unreadable output of an encryption algorithm. That data has been scrambled and is not readable to the human eye. And finally, we have cleartext. Cleartext is just readable data transmitted or stored unencrypted. And now plaintext can either be cleartext or ciphertext. Plaintext does not necessarily have to be readable. Now before we move on, let's see what you guys remember with the pop quiz. So what is the main purpose of cryptography? Is it A, to ensure the confidentiality of the data, B, to compress the size of a data string, or C, to ensure data can be publicly viewed? And the answer is A, to ensure the confidentiality of the data. Remember, we use cryptography to hide our messages. Now in encryption, there are two factors that determine the strength of the encrypted data. The first is the secrecy and who has access to the key, which is a randomly or systematically generated stream of numbers used as an input to encrypt and or decrypt data in a cipher. And the second is the strength of the cipher itself, which is the encryption algorithm or mathematical function used to encrypt data. And we have two different types of ciphers. The first is the classical, and the second is modern. Classical ciphers are relatively weak in comparison to modern ciphers, especially if the translation table or patterns are recognized. The first of the classical ciphers is the substitution cipher. In the substitution cipher, every character in plaintext is represented or substituted by another character. One character actually means something else. And in the following example, we have the Caesar cipher, where every letter is represented by the third letter down. As you can see here, the letter A is represented by the letter D. The letter B is represented by the letter E, and so forth. And so if we have a plaintext of Cybrary, the following ciphertext will look like the following: FBEUDUB. Now in transposition cipher, which is the second of the classical ciphers, the identity of the characters remain unchanged. but their position is rearranged to create the ciphertext. Every letter and character retains its value and what it represents. It's just that the characters are all scrambled up based upon a pattern or a translation table. So, for example, if we have the following translation table, the first character of a plaintext will be located at the 14th position of the ciphertext. So if we have an example of the following, the plaintext is I am Lord Voldemort. In the ciphertext, as you can see here, the first character, which is an I, will be located at the 14th position of the ciphertext. I, right here. And the ciphertext will essentially read Tom Marvolo Riddle. And now for a pop quiz. Which of the following is a classical cipher? A, substitution, B, asymmetric, or C, symmetric? And the answer is A, substitution. Substitution is a classical cipher, while asymmetric and symmetric are both modern types of encryption. And now moving on to modern encryption. We essentially have two types of modern encryption, symmetric and asymmetric. In symmetric encryption, a system will use one key to both encrypt and decrypt messages. This key is usually called a shared private key and is shared between two systems who want to communicate with each other. They will use the same key to encrypt and decrypt. This key is usually kept private and has less overhead than asymmetric encryption. And we'll go through a brief example. So if we have Alice and we have Bob, and if Alice wants to send a sensitive document over to Bob through the internet, and she wants to prevent from Evil Eve from seeing this document, she'll use a shared private key and encrypt that file or data with that shared private key to create a ciphertext, and she'll send that over the internet. And now Evil Eve can't see what she's originally sending. And once Bob receives that ciphertext, he will use that same shared private key to decrypt the message, and he will receive the original contents. So now for asymmetric encryption, each system will have two keys, a private key and public key. Relatively, one is used for encrypting and the other is used for decrypting depending if that system is receiving or sending the data. Both keys are derived and related to one another. In addition, the public key will be accessible by anyone, but the private key for each system will remain a secret and exclusive to themselves. So the encryption process is much more complex than the symmetric process because if two systems want to talk to each other, it will require a sender's private key and a receiver's public key to encrypt a message, and the receiver's private key and the sender's public key to decrypt the message, resulting in a more overhead and longer encryption process. And we'll go through another example again. So if we have Alice and we have Bob again, and Alice needs to send a sensitive document over to Bob via the internet, and we have Evil Eve wanting to eavesdrop, Alice will take her private key and Bob's public key and encrypt that document or data to create a ciphertext. Now that ciphertext is sent via the internet, and Evil Eve cannot get into that ciphertext or view it because he or she does not have Bob's private key. Now, that ciphertext is sent over the internet, and Bob receives that ciphertext. Now, Bob will use his private key and Alice's public key, which is readily available, to decrypt that message, that ciphertext, and get the original contents of that message. And as you can see, asymmetric encryption uses a total of 4 unique keys, unlike symmetric, which only uses 1, resulting in a slower encryption process. Now for the final quiz of the lesson. Which modern encryption method utilizes only 1 key, resulting in faster encryption and decryption? Is it A, symmetric, or B, asymmetric? And the answer is A, symmetric. Symmetric uses only 1 key to encrypt and decrypt between both hosts. And now to summarize. Today we reviewed some encryption theories and how we use encryption to protect and ensure confidentiality of data. We reviewed and learned 2 different ciphers, substitution and transposition. And we went through the modern encryption methods and the differences between symmetric and asymmetric encryption. Everything we learned here today is used in understanding the foundations when we are protecting data in transit. Thanks for tuning in, and I hope to see you in the next episode.